Hello, and welcome to another digital lecture for Salt Lake Community College. This lecture will continue to cover Section 4.1 for Introductions to Statistics, examining quantitative data. There are only a few definitions in this section that we would like to be comfortable with. The first is the definition of shape. When looking at quantitative data and histograms, it is common to want to look at the shape of a distribution. The shape will describe the overall look of the distribution. There are several typical shapes that we will see when looking at histograms. The first that I will discuss is when your data is right-skewed. This is when the data will trail off to the right and have a longer right tail, with most of the data falling on the left. While there will be some variation in right-skewed distributions, the general shape shows that there is a higher frequency of data falling on the left-hand side, and then as you move to the right-hand side, the frequency of values of those variables are less. Some examples of data that might show a right-skewed distributions might be U.S. household income. When thinking about U.S. household income, a higher frequency of households will have a lower income, while a lower frequency of households will have a higher income. The same could be said for house prices. There is a higher frequency of house prices that are in the lower range, and a lower frequency of house prices that are in this upper range. Other variables that might show a right-skewed distribution could be reaction time or the number of children in the family. We will also see left-skewed distributions. Left-skewed distributions have the reverse characteristic to a right-skewed distribution. This is when your data will trail off to the left and have a long, thin tail to the left, with most of the data falling on the right-hand side. Again, there will be some variation in left-skewed distributions, but the overall trend will show a higher frequency of data falling on the right and a lower frequency of data falling on the left. Some examples of data that might show a left-skewed distribution might be age of death. There would be a lower frequency of people that have a low lifespan, and a higher frequency of people that have a longer lifespan. The same could be said for the distance of the long jump in the Olympics. Most people competing in the long jump in the Olympics are going to be able to jump pretty far. However, there are some people that will not be able to jump that far. There'll be a lower frequency. The same could be said about your age of retirement. Most people will retire at this higher age, and there are some people, less frequently, that will retire at a younger age. We also talk about symmetric or bell-shaped distributions. This is when your data will trail off in both directions and have a more common occurring value of your variable. Again, there will be some variation with symmetric bell-shaped distributions, but the general shape is they have a more commonly appearing value, someplace in the middle of the value of the variable, with less occurring values in the upper or the lower regions. Some examples of data that might show a symmetric or bell-shaped distribution might be the heights of people. A majority of people will have a height someplace in the middle. It'll be the more common height. And then there will be a less frequent number of people that are really tall and a less frequent number of people that are really short. Similarly, we can talk about IQ scores. There is a more common IQ score someplace in the middle where most people have an IQ score. And then there are fewer people that have a really high IQ score or a really low IQ score. The same can be said about the variables shoe size or birth weight. The last distribution shape that we would like to discuss is referred to as a uniform distribution. This is another symmetric type of distribution where all the values of the variable occur roughly at the same frequency. Some examples of variables that might follow a uniform distribution would be the chance of landing on any number of a six-sided die. Each of the values of a die will occur at roughly the same frequency. That is, the chance of rolling a 1 is the same as the chance of rolling a 2, which is the same as the chance of rolling a 3 or a 4, a 5, or a 6. Another variable that might follow a uniform distribution would be picking the winning lottery numbers. Now, a common topic that some students get confused about is being able to identify the skew in a distribution. So let's talk about that for a moment. We use the long tails to identify the skew of a distribution. When the data trails off in one direction, the distribution is said to have a long tail. If the distribution has a long left tail, then we say it is skewed left. If the distribution has a long right tail, then we say it is skewed right. It is sometimes helpful to imagine drawing the shape of the distribution over your histogram to identify the shape of the skew that you're looking at. Another characteristic that we would like to talk about with histograms and shape is referred to as the mode. The mode is shown as a prominent peak in your distribution. It is the value of the most occurrences. When looking at your distribution, you will sometimes be able to see one mode or one prominent peak in your distribution. This is referred to as unimodal. So it would be one prominent peak or one most occurring value. Other times you may see distributions that have two prominent peaks. In this scenario, you are seeing what is referred to as a bimodal distribution. Again, that is when there are going to be two prominent or two most occurring values. And sometimes in our distribution, we will see more than 2 prominent peaks. In these scenarios, we will say our distribution is multimodal. Here, I'm showing a distribution that maybe has 3 prominent peaks, or 3 more occurring values. Now, when looking at your distributions and looking at modes, it is not about finding a clear and correct answer about the number of modes in your distribution, which is why the word prominent is not rigorously defined. The more important part of the examination of your distribution is just to better understand how your data might look and how it might be structured. This about covers all the definitions for section 4.1. If you have further questions, be sure to review the example videos that follow or ask your instructor.